Welcome to the lesson on power. In this lesson, we will focus on power, watts, and how it plays a crucial role in various aspects of battery electric vehicles, abbreviated as BEVs. Let us look at our lesson objectives. By the end of this lesson, you will be able to define power. Next, you will be able to explain the concept of watts, abbreviated as W. Next, you will be able to identify the factors that can influence power consumption, watts, in a BEV. BEVs revolve around power, and understanding how it's measured is crucial for technicians. Power is a general term for the rate at which energy is used or produced. We will focus on watts. A watt is the fundamental unit for measuring power in a BEV. Understanding watts is critical as it plays a central role in various aspects, including diagnosing performance issues, recommending optimal charging solutions, troubleshooting electrical systems, and ensuring overall vehicle health. In this lesson, we will focus on understanding watts and the various factors influencing watts. Let us look at the term power to learn what a watt is all about. What is power? Power is the rate at which electrical energy is transferred over time in a circuit. It tells you how fast electrical work is being done. In a circuit, electrical power depends on the voltage, pressure, and the current flow of electrons. So, what is a watt? A watt is a unit of electrical power. 1 watt is equal to 1 joule of work done per second. A joule is a unit of energy, and a second is a unit of time. So, watts tell you how much energy is used or produced each second. Another way to understand watts is to think of it as the rate at which a device converts electrical energy into another form, like light, incandescent bulb, or motion, electric motor. For example, a typical LED light bulb might use around 5 watts. BEV fast chargers deliver a high number of watts, often several kilowatts, with 1 kilowatt equals 1,000 watts. For instance, a fast charger delivering 50 kilowatt provides 50,000 watts of power. This high wattage allows the charger to significantly replenish the vehicle's battery faster than a standard charger with a lower wattage output. Watts are used to describe the power of electric motors, indicating how much energy they can convert per second, the output capabilities of the battery, and the power consumption of various electrical components within the vehicle. Understanding the factors affecting power, watts, is crucial for optimizing performance and efficiency. Let us now look at some of the factors that influence power. They are voltage and current, motor efficiency, battery capacity and health, vehicle load and efficiency, driving conditions, and regenerative braking. Let us now look at each of these factors. The formula P equals V times I tells us that power, P, is directly proportional to both voltage, V, and current I. This means an increase in either voltage or current will change the vehicle's power output. For example, a fast charger, higher voltage, can significantly boost power delivery for faster battery charging. Conversely, during heavy acceleration, the current draw on the battery increases, resulting in higher power usage. In BEVs, the electric motor's efficiency plays a critical role. It determines how effectively electrical power, watts, is converted into mechanical power that drives the wheels. Less efficient motors require more watts to produce the same amount of mechanical work, leading to higher power consumption. The health and capacity of the battery directly affect the amount of power, watts, it can deliver. A battery with a lower capacity may not be able to provide the same peak power output compared to a healthy battery. Over time, battery health can decline, reducing its ability to hold a charge and deliver peak power output in watts. The total electrical load on the vehicle, lighting, infotainment systems, climate control, etc., and aerodynamic drag influence power consumption. More electrical load or higher wind resistance requires the motor to use more watts to achieve the same performance. This means the more work the car needs to do, electrical or overcoming air resistance, the more power, watts, it will use. Driving conditions like speed, acceleration patterns, and road incline also impact power usage. Rapid acceleration and driving uphill require more power from the motor as it needs to overcome greater resistance. Conversely, maintaining a steady speed on flat roads consumes less power. Regenerative braking systems play a unique role in power dynamics. During braking, they capture the mechanical energy that would normally be lost as heat and convert it back into electrical energy. This captured energy is then fed back into the battery system, increasing the battery's power reserves and improving overall efficiency. Let us now recap what we have covered in this lesson on power measured in watts. Power is the rate at which electrical energy is used or produced. A watt is the primary unit for measuring power. Watts plays a central role in diagnosing performance issues, recommending charging solutions, troubleshooting electrical systems, and ensuring overall vehicle health. Watts quantifies how much energy is used per second. Factors influencing watts are voltage and current, motor efficiency, battery capacity and health, vehicle load and efficiency, driving conditions, and regenerative braking. It's important to understand these concepts prior to working on BEVs. Thank you.